Good morning. We're going to do sine and cosine waves, and specifically talking about amplitude and period. Amplitude and period. We have looked, just to do a little bit of review here, we have done y equals sine of theta and y equals cosine of theta. And let me just cut that. Okay. And we've looked at their graphs. All right, so there would be that one and that one. And we saw that, you know, these are divided up into a different color. This divided up into pi over 2, pi, 3 pi over 2. And if you don't understand where these things come from, you need to watch the other videos first, certainly. This is pi over 2, pi, 3 pi over 2, and 2 pi. Quickly, their graphs look like this. So if we had, we'll make the first one, our base one, we'll make it yellow. So it would start here. That's not yellow. That would be green. It would start right here and go up to 1. Of course, its amplitude would be 1. It would go up to here, down to here, down to here, and back up to here. And that would be a basic sine wave. I'll try to do that the best I can. Perfect. Totally hit that. There we go. And a cosine wave would behave slightly different. Its amplitude would still be 1 and -1. Well, its amplitude would be +1, but it would go up and down 1. But it starts up here, comes down through here, bottoms out here, back up here, and tops out here. So it goes like this. And that's what a basic cosine wave looks like. Now let's mess around with different things. Now I have the luxury of doing layers on this, so I could do a lot of different graphs on this, and I'll show you how it affects things. So let's say I had, now be careful when you're doing this, because your graph will turn into a mess, but let's say I had 1/2 sine theta. Well, if I did that, the only thing that would change is the amplitude. Now let's review what this looks like. The basic formula is A sine bx, not bx, let's put b theta, plus c. A sine b theta plus c. This b right here is the frequency, and this a is, of course, the amplitude. So what we're looking at is on our basic y equals sine of theta, that's actually 1 sine of 1 theta plus 0. I mean, it is in this form right here. It is in that form. But we usually don't write 1, I mean, being, you know, like if you have the number 7, we don't put 1 times 7, we just write 7. But how this graph would be different is its amplitude would be half. It would be 1/2, so it would only go up to here, up to 1/2. Everything else would be exactly the same, except that dot would be here, it would still pass through here, and it would be here and here. So its graph would be basically half as big, but you can see its period, or the length of one cycle, is the same. It's the same. In order to change the period, we have to change this number right there, which we have not done yet. So if we come over here and do the same sort of thing on the cosine, y equals, and let's say this time we did 2 cosine theta, well, that would make it come up to here and down to here, -2. And so it would behave the same way. It would still pass through this point, but it would start up here, but it would bottom out down here. Something like that. It would go, its amplitude would be stretched like that. That would be the graph of 2 cosine theta. All right. Now, if you need to go back and look at that, go back and look at it. let's do something different. Let's say this time I had negative. What would happen there? Let's say I had negative 2 sine of theta. Well, if it's negative 2, then that means all the values on the chart, and you know what chart I'm talking about because we made those charts for 2 days. Those charts would, all the values on the y column there would get multiplied by negative 2, which would, what would happen to this graph is it would flip it. It would flip it over. So before I do 2 sine theta, I'll just sketch this. If I did, let's say in red here, y equals negative 1 sine theta, well, what that would look like is instead of going up first, it would still start here, but it would go down, and then up and up and down. So it would go like this. And you can see that that's kind of a almost like reflection, like the mountains reflecting in the water kind of deal. That's what happens when you change a sign. Okay, and you make it negative. It just flips the thing over, kind of like rotating it. And let me just delete all that. We don't need that right yet. What I would like to do is negative 2 sine of theta. All right? Well, I know for one that the amplitude is going to be 2, okay? Which means it's going to go up farther, up here to 2, and down here to negative 2. And everything else is going to be the same, except it's also negative, which means it's going to start and go down. So the next point would be here, and then up to here, and then here, and down here. So it's going to go down, farther though, it's going to go to 2, up, and then back down. The whole point of this video is just to introduce all this and show you all this stuff. Let's say for this green graph here, though, the book's going to ask you to identify the amplitude and the period. All right, and it's the first time we've really done anything with the period. For the amplitude, it's going to be this number here. All right, remember, it's y equals a sine b theta plus c. A is the amplitude, and it's the absolute value of it. So what would the amplitude of this green graph be then? It wouldn't be negative 2, though, because it's the absolute value. So it's the absolute value of negative 2, which was 2. That would be your amplitude. The period, to review that concept, the period has a formula attached to it. It is 2 pi over b, where b is the frequency of this graph. Well, what is the frequency? What number is in there in front of that theta right there? It's 1. So this is just the period of this graph is 2 pi over 1, which is 2 pi. And the period, of course, is the time it takes to make one wavelength. So it goes, both of these graphs would have the same period. It isn't until I go messing with this number in front of theta that the period changes. You know, this might go out 8 pi or 2/3 pi or something weird like that. All right. So now to wrap this up, let's see how we're doing on time here. Let's do one more. Get rid of all of this, all of that. And let's say that I wanted to do y equals, let's say, negative 1/2. I'm going to pause this and have you try this. Sine of 4 theta. Okay, here's what I want you to try to do. Let's see if you got this or not. First of all, we'll make a little graph. Down, over. And I want you to find the amplitude, the period, and sketch me a little picture as best you can of the graph. Okay, I'll be back in a second. All right, get a different color. What is the amplitude of this? Well, it is the absolute value of negative 1/2, which is 1/2. Okay, that tells us, and by the way, we should be labeling this. This is pi or theta radians, and this is going to be the sine of theta. So that, labeling our axis is important. The amplitude is 1/2, so I'm going to go ahead and just go 1/2 here and negative 1/2 here. I think that's important. And now we need to figure out what the period is. So to do that, the period equals 2 pi over b, where b is what? Hello? B is 4. This right here is b. So it's just 2 pi over 4, which is 1/2 pi, or pi over 2. So this thing has a very short period. It is pi over 2. So if we graph this, it's going to come out 2 here. Now I'm just introducing this, and I don't want to go, because this video is taking forever, to get the other, because when you make a sine or cosine wave, you need 4 spaces. I think you can see what I mean by spaces. I mean like 4 of those distances right there. Okay, so 1, 2, 3, 4. So I got 1 space, 2 space, 3 space, 4 space. That's what you need in order to graph this. Now, as far as what these are, what the divisions of these are, I'll just throw this out there. We'll work on it tomorrow. You take this value divided by 4, and that's what this is, and then you add to it. Okay? So in other words, if this was 4 pi, each of these would be 1 pi. All right, so that's all I'm going to say about that. This is also, we got lots of other things going on here. This is negative, okay? But it is a sine function, which means it starts here. It's negative, though, so this interval would be down here. Then it would go through here, up to here, and back down to here, okay? So it would look something like this. Just a little quick sketch. And back down. And that would be the graph of that. And like I said, we'll work on what these values here are, but I think you can see, in fact, that they're going to be the eighths, right? This is going to be pi over 8. This is going to be 2 pi over 8, which is pi over 4, and this is going to be 3 pi over 8. And I invite you to think about why that is. I will talk to you later.